Hello friends, I welcome you in lecture number 15 on random variables. In this lecture we are going to discuss one more example on finding distribution function of a continuous random variable. So let's start with this example. We are given that in a certain district the proportion of highway sections requiring repairs in any given year is a random variable having this probability density fx equal to 12x square times 1 minus x if x is in between 0 and 1 and 0 otherwise. So we are asked to find out distribution function for this PDF, and using that distribution function we have to determine the probability that at least half of the highways sections will require repairs in any given year. So here we are given that random variable is the proportion of highway sections requiring repairs in any given year. So we know that the proportion of highway sections requiring repairs in any given year can take any value on the real line. So here random variable can take any value so that it is a continuous random variable, and this is the probability density function, probability density, or you can say probability density function for that random variable. So first we have written that random variable x is the proportion of highway sections requiring repairs in any given year, and we have written this probability density function. Now we try to find out distribution function. So the definition of distribution function is capital F of A equal to probability that capital X is less than or equal to A, which is integral of probability density function over the interval minus infinity to A. A is any real number. Okay, so we know that distribution function is a function from R to R, and it is defined in this way. Now here our function is different in different parts on the real line. In this interval value of function is non-zero and otherwise it is 0. That means if we consider this real line, suppose this is 0, then this is 1. So in this interval fx is non-zero and it is 0 otherwise. So we have different cases here also in writing distribution function, because distribution function is integral of probability density function, and probability density function is different in different parts of the real line. Okay, so we will consider three cases. We will find out value of f of A if A is to the left side of this interval, that is if A is negative. We will find out value of this f of A if A lies in between 0 and 1, and we will find out f of A if A is to the right side of this interval or if A is greater than 1. So we consider all these cases one by one. So first we consider if A is negative, and we use this definition. A is negative, so we start by writing this f of A is given by minus infinity to A fx dx. So we are integrating fx over interval minus infinity to A. So here we are integrating with respect to x, so x is obviously less than A and A is negative, so that means x is negative, and if x is negative value of fx is 0. So here we can put fx equal to 0 in this interval, fx is 0. Okay, and we can write this reason because x is less than A implies x is negative and therefore fx is 0. So if A is negative, value of distribution function is 0. So f of A equal to 0 if A is negative. Now we consider A in this interval, in interval 0 to 1. So that is second possibility or second case. So now we find out value of distribution function if A lies in between 0 and 1. So again we write down that formula for distribution function is minus infinity to a fx dx. Now a is in between 0 and 1 and we have to go up to a. So we can break this into two parts. First we because a is in between 0 and 1 and value of fx is different in this interval and it is different to the left side of this interval. So because fx is different to the left side of 0 and fx is different to the right side of 0, we break this interval into two parts. We first go up to 0, minus infinity to 0 fx dx, and we consider 0 to a fx dx because fx is different for x negative and fx is different if x is in this interval. Now in minus infinity to 0 fx is 0 because x is negative, and in 0 to a because x is in between 0 and a, okay, we can write 0 less than x less than a implies, and a is less than 1. Here x, we are integrating with respect to x from 0 to a. So from this we have 0 less than x less than a, and a is in between 0 and 1. So this implies x is also in between 0 and 1. So this implies fx is non-zero, that is 12x square times 1 minus x. Okay, so we are using this fact. If x is in between 0 and 1, fx is 12x square into 1 minus x. So here I write fx equal to 12x square times 1 minus x dx. So now this is 0 plus this we can rewrite as 0 to a 12 times x square minus 12 times x cube. Integration is with respect to x. So this is equal to, now we can integrate. Integral of x square is x cube by 3 minus 12 times integral of x cube is x raised to 4 by 4. Limits of x are from 0 to a. So we can further simplify this. Here 3 will cancel out, here 4 will cancel out. So we have 4 times x cube minus 3 times x raised to 4. Limits of x are from 0 to a. So this becomes 4 times a cube. First we put x equal to a minus 3 times a raised to 4, and for lower limit we have 0. So this is value of distribution function if a is in between 0 and 1. So therefore f of a equal to 4 times a cube minus 3 times a raised to 4 if a is in between 0 and 1. So this is this second possibility, that if a is in this interval 0 to 1, f of a is 4a cube minus 3a raised to 4. And the last possibility is if a is to the right side of that interval 0 to 1, that means if a is strictly greater than 1. That means we are on this side, our a is somewhere here. So now we try to find out value of distribution function if a is greater than 1. So here we have minus infinity to a fx dx by the definition. Now a is here, and we have obtained a value of distribution function up to this point. Okay, here we can see, we can find out f of 1 here. For a equal to 1 we will be able to find out f of 1, and in this part a value of f of a is 0. Okay, so we can write directly, we can write that this is equal to minus infinity to 1 fx dx plus 1 to a fx dx, because function is different to the right side of 1 and function is different to the left side of 1. Now this is nothing but, by the definition of distribution function, it is f of 1. If we use this definition again, if we put a equal to 1, we have f of 1, and if we are to the right side of 1, that means here x lies in between 1 and a, because 1 less than x less than a, and here from this 1 less than x less than 1 we obtain that x is greater than 1, and if x is greater than 1, value of fx is 0. So here we write 0. So therefore this is equal to f of 1 plus 0, integral of 0 is 0, and f of 1 we can obtain from this simply by taking a equal to 1. So if I take a equal to 1, here I have 4 times 1 cube minus 3 times 1 raised to 4, that is going to be 4 minus 3, which is 1. So f of 1 is 1, or we can write here also f of a is 4a cube minus 3a raised to 4. So that becomes 4 minus 3 equal to 1. So if a is greater than 1, value of f of a equal to 1. So therefore f of a is 1 if a is greater than 1. So in this way we have decided value of distribution function in different parts of the real line. So we summarize all these three cases and we write down the distribution function of a given random variable. So therefore the distribution function of random variable capital X is f of a equal to, we have three possible cases. First case was if a is negative, second case is if a is in between 0 and 1, and if a is greater than 1. So here we just obtain that it is 1, here it is 0, and in between 0 and 1 it is 4a cube minus 3a raised to 4. So this is the distribution function of random variable x. If you wish, you can replace this a by another variable, dummy variable x also. So this a or x is a dummy variable. So now we have obtained the first part of given problem. We had to obtain that, find the distribution function and use it to determine the probability that at least half of the highways sections will require repairs in any given year. So now we have to determine this probability. So the second part of the problem is the probability. We are asked to determine the probability that at least half of the highway sections will require repairs in any given year. So that means we have to decide the probability of some event. Now random variable x is the proportion of highway sections requiring repairs, in any given year, and we are asked to find the probability that half of the highway sections will require repair in any given year. That means random variable x is greater than or equal to half, that is 1 by 2. So the half of the highway sections requiring repairs in any given year can be represented by this event. that the proportion is at least 1/2. So we will consider this probability as probability that random variable x is greater than or equal to 1/2, because we are asked to find out the probability that at least half of the highway sections will require repairs in any given year. That means proportion is greater than or equal to 1/2. Now this we can rewrite as 1 minus probability that x is less than or equal to 1/2, because these two events are disjoint. X is greater than or equal to 1/2 and x is less than 1/2 are disjoint events. Okay, if we wish we can simply write strictly less than also, because we know that for continuous random variable, if we write equality or if we don't write equality, no problem, because probability at a point 1/2 is 0 if x is continuous random variable. So it does not matter whether we write less than or equal to or strictly less than 1/2. Now this is nothing but value of distribution function at 1/2, okay, because f of a is nothing but probability that x is less than or equal to a. So this is nothing but value of distribution function at point 1/2, and 1/2 is in between 0 and 1. So if value of point A is in between 0 and 1, then this is the formula for distribution function 4a cube minus 3a raised to 4. So we are interested value of distribution function at point 1/2. So we will put a equal to 1/2 here. So 4a cube minus 3a raised to 4, that is 4 into a cube minus 3a raised to 4, we put a equal to 1/2. So this is now 1 minus this is 4 into 1/8 minus 3 into 1/16. So this is nothing but, here we can write 4, we can multiply by 2. So this we can write as 8/16 minus 3/16. So we have 16 LCM, and this is 5/16, and 16 minus 5, that is 11/16. So this is the required probability that at least half of the highway sections will require repairs in any given year is 11/16. Required probability is 11/16. So in this way we can determine the distribution function of a given continuous random variable, and using that distribution function we can decide the certain types of probability. So this is all about this session. I hope you like it. Thank you very much.